This video continues on with the crude oil topic. So crude oil does give out all these different mixtures, different compounds, and they're all hydrocarbons. But most of them that it gives out in its fractions are alkanes. And although alkanes are very useful for different things, they are not the most useful. And in fact, they're not alone in what we can produce from the crude oil. The other part of what we can produce is alkenes. But alkenes are very useful. We use them in a whole lot of different things because they can be polymerized, as is gone over in another video. So polymerization just means you can put them together into one long chain. Okay, but if we start off with alkanes and what they can be used for, then we'll get an idea of the trends in their characteristics. So short alkanes are the most volatile and the least viscous. Now, viscous. So, being viscous means if it's very viscous, it doesn't run very easily. If it is not very viscous, then it runs very easily, like a very kind of thin liquid rather than a thick one. So volatile means it evaporates easily. And the higher the volatility, the easier it will evaporate. Obviously, if things are volatile, they also are more likely to be easily set on fire, because if something evaporates easily, then it can easily form a gas, and gas more easily bounces around the room because the particles aren't joined together, and will eventually maybe find a spark that would set it on fire. So that also means that volatile short alkanes are actually more dangerous if they're not held under a high pressure in a container. For example, the camping gas explanation before was given for a refinery gas, which is the smallest chain hydrocarbon, so it is a very short alkane group and therefore very volatile and very gaseous. Okay, so because alkanes that are short are volatile and not very viscous, they're really useful for certain things. I've already given one example, which is refinery gas. And that's actually the one that came out the top of the fractionating column. Top of column, okay. Now, and then we had petrol. Petrol comes out pretty close to the top. We know what that's used for. Cars. Okay. Now, another thing that can be used is actually the low viscosity things. The things that are actually no, the high viscosity things and low volatility things. So, high viscosity plus low volatility. And these are the long chains, okay? So long chain hydrocarbons. So let's just call them HCs. Now this includes bitumen. Bitumen. Okay. So that can be used as road tar. And obviously we all know road tar is basically solid, but when it's put down on the road, it's actually a very viscous liquid, which means it's a liquid that doesn't run very easily. So you might have seen marks in roads where maybe cars have driven over them before the bitumen was actually solidified. That's when the imprint of it is put into the liquid bitumen, which is actually very viscous but can be pushed down. Okay, so obviously crude oil is really important. We use it to generate electricity. We use it in our power stations for that. We also use some kind of things like fuel, like petrol, and we even use gas in our homes for cooking and keeping central heating. We can also use alkenes especially to produce plastics, but they're also used for very crucial things like medicine. So, alright, so crude oil fractions, yeah, they're used for fuel. Fuel's the obvious one, but also medicine. And I mean, even tar on the road and engine lubricants, so that the parts of engines don't just kind of rub against each other, cause a lot of friction, and maybe set the engine on fire or just destroy parts in the engine. So obviously we would say that if we were going to do without all of these, we'd still want to have the medicine part, wouldn't we? So a lot of people argue that because crude oil is non-renewable, meaning we're going to run out of it one day, that we should only use it for medicine, because medicine is probably the most important thing for keeping us humans alive. Okay, so a lot of people, now this might be an extreme view, but a lot of people think that crude oil should only be used for medicine and we should stop using it for fuels. And that's because while medicines can only really be made out of crude oil fractions, other things can be made out of other things, right? So for example, just to clarify that, fuels could also come from ethane now. Okay, so we call these kind of biofuels. Biofuels because we can make ethane from fermenting different substances. We can get it from fermenting corn, and people are actually growing corn to produce ethane these days. So instead of using crude oil for all of these things, we could just use it for the medicines. That's what some people say. And we could use other things like ethane, which we all know is an alcohol because it has the OH functional group, which is the alcohol functional group. So we could use ethane for fuels, we could use it for engine lubricant probably, or something similar, and we could save the non-renewable crude oil fractions for medicine, which is what we really need it for. Okay, so there's also the options of wind power and nuclear power. Okay, now there are different negatives to both of these. So, for example, wind power, well, it relies on there being wind. Alright, and nuclear power relies on us getting rid of waste. And obviously, if we remember Japan's hazardous situation where they had a nuclear kind of dysfunction in their power plants and a release of nuclear waste into the atmosphere, then we also have that huge risk of nuclear. Well, it's not a huge risk, but there's a small risk of a huge event. Okay, so it's a small risk. It doesn't happen very often, but when it does happen, it's huge. And that's why there's a lot of political and social distrust of these things. And wind power obviously relies on wind, which isn't always available. So maybe we'd have blackouts at night or at certain times of the year when it's not as windy. So another thing that we need to remember is that crude oil can be cracked, which is just basically we are changing an alkane into alkenes. So often, actually, it's not just alkenes, but you get an alkane and an alkene. So we're splitting huge, really viscous, not runny, and not easily evaporated long chain alkanes or fractions of crude oil into smaller ones, which are actually sometimes more useful. Okay. So for example, we could take maybe kerosene, which is a classic example, and we could put it over a certain reactant, which will help us. Well, it's not a reactant, it's a catalyst, okay? So we put the catalyst on the arrow if we're drawing this out. We put it in the middle, because it's not a reactant. Reactants go on the left, and products go on the right, but catalysts go in the middle of the arrow. So the catalyst we could use to crack something. So we're talking about cracking and it's mainly long chain hydrocarbons. So let's just call it long chain HCs. So we're cracking it using a catalyst, and kerosene would crack to give us maybe octane and ethene. Okay, so we'll see how this works later, because basically you always have to have the same element numbers on this side as on that side. That's what we've learned from balancing equations. Okay, so let's look at the catalyst that we use to crack these things. So in this situation we could use aluminium oxide. Now if we look at how this works, we can see that on the left side kerosene will have the same number of carbons as on the right side. Okay, and on the right side those carbons will be made up by two compounds, octane and ethene. So how many do you think ethene has? Well, we know methane methane has one, doesn't it? And we know that ethene is a version of ethane but with a double carbon bond. So ethene has 2 carbons, octane has 8 carbons, which means on this side we must have 10 carbons with the kerosene. Alright, so we're going from 10 carbons here to 2 carbons and 8 carbons here. Now if we remember how we work out the number of hydrogens for each of these, for an ethene it's just 2n, isn't it? And n here is 8. So it's H. So it would actually look like this if we were going to draw it out. C8H16. So it's a huge one for oh no, look, I've done octane there, so no, it's wrong. For an alkane it's 2n plus 2, so it would be 2n, which is 16, plus 2 is 18. Okay, so it would actually be 8 carbons and 18 hydrogens. And then for the ethene, now we can do it properly, it would be C2H4. Okay, and kerosene is C10H22. Okay, so that's basically all you have to remember. They use a catalyst to crack long chain hydrocarbons and form short chain ones, and usually it'll be made up of a alkane and an alkene on the right side after the catalyst is split or cracked the long chain hydrocarbon. Okay, so as well as using a catalyst though, and that catalyst will mostly be aluminium oxide for exam purposes, you can also remember that you need it to be a powdered aluminium oxide. Okay, so a powdered version, al oxide, and you need there to be high temperature of about 400 to 700 degrees, so really high. It's like 4 times the boiling point of water, and that will allow the energy in the molecules or compounds to reach such a point that when they collide, they will definitely react. And in this case, it's not exactly a reaction of different molecules, but it's a reaction where this is split on the surface of the aluminium oxide to give you these things. So it doesn't react with that, it just simply splits to give that at that temperature. So that is basically what cracking is. And just to remember a few products that we actually need from cracking. We can get petrol from cracking, because we actually produce a lot more diesel than petrol. So to produce petrol back, we crack it. Okay, and diesel can also be cracked to give us different things like paraffin, which we can use for burning in lamps and things like that. In the olden days they were used in paraffin lamps. Okay, ethene is also a really common one. Ethene is the C2H4 compound we looked at before, and C2H4 is really good for making plastics, and that is because it can be formed into polymers, which is actually talked about in another video. So hopefully that'll help you understand cracking and crude oil in general.